Boyle's law is an ideal gas law where at constant temperature, the volume of an ideal gas law is inversely proportional to its absolute pressure. The formula for Boyle's law is P1V1 equals P2V2. Pressure times initial volume equals final pressure times final volume. P1 is equal to initial pressure, V1 is equal to initial volume, P2 is equal to final pressure, and V2 is equal to final volume. The balloon on the left is larger because the pressure on the outside is lower than the pressure on the inside of the balloon. The balloon on the right is much smaller because the pressure on the outside is greater than it is on the inside.
Charles' law. It is a special case of the ideal gas law. This law only applies to ideal gases held at a constant volume, allowing only the pressure and temperature to change. The formula is V1 over T1 is equal to V2 over T2. V1 is equal to initial volume, T1 is equal to initial temperature, V2 is equal to final volume, and T2 is equal to final temperature. Hotter temperature makes the volume increase. The colder temperature makes the volume decrease.
Gay-Lussac's law. It is another special case of the ideal gas law. This law only applies to ideal gases held at a constant volume, allowing only the pressure and the temperature to change. P1 equals initial pressure, T1 equals initial absolute temperature, P2 equals final pressure, T2 equals final absolute temperature. A thermometer is used and showing that when temperature increases outside of the thermometer, the pressure inside also increases, pushing the mercury inside the thermometer up.
The ideal gas law determines the number of particles of a sample of gas by utilizing the relationship between the pressure, volume, and temperature of the sample. The ideal gas law formula is PV equals nRT. P stands for pressure, V stands for volume, N stands for the number of moles, R stands for gas constant, and T for temperature. An example of a real-world application for this law is a gas being produced in a reaction. In this picture, after we have found the number of moles of gas, we can use the ideal gas law, which is the PV equals nRT, to find any other missing factors.